All right. Hey, everybody. I wanted to try something a little new where I'm giving you a video that you can watch the lecture kind of over and over if you needed to. So I wanted to talk to you a little bit about those safety devices that I was asking you about last week. Okay. And specifically, a lot of you guys mentioned that the valuable things, classically, you're teenagers. I feel the same way. But you guys mentioned a lot of electronic devices, right? We want to save our phones because when they fall and hit the ground, that's when we get into trouble and they start kind of just exploding. The word that you guys described kind of for the safety devices was that all of the cell phone covers seem to cushion, right? They're softer. They protect it by cushioning the blow. So we want to talk about what happens with that cushioning and why that helps kind of protect the device. So I want to bring you back to two topics that we talked about during the first semester. The first topic right here would be talking about XVA and the idea that acceleration is really how much time it takes to slow down or speed up. Okay, so for example, let's say this phone is falling at 10 miles per hour, and then hits the ground, and all of a sudden, when it hits the ground, it's going 0 miles per hour. So it has slowed down quite a bit. Well, the same thing happens here. The phone might be traveling 10 miles per hour, and it still slows down to 0 miles per hour. So it slows down the same amount. The question is, how long does that take? Okay, when something slows down very quickly, so when the amount of time, do this in red, when the amount of time that it takes to slow down is very small, like this, the acceleration of the object is very big. Okay. I also want to remind you of, this was Newton's second law. And that was the idea that in order to have acceleration, we needed force or an unbalanced force. So if the unbalanced force goes up, the acceleration goes up, and vice versa. So what happens in this next kind of topic is we're going to combine these two things into the idea that the change in speed, whether we speed up or slow down, is really closely related to what would it be? It would be the force times the time. Okay? And what all of our devices are trying to do is saying, like, look, no matter what, we're going to speed up or slow down 10 miles per hour. But if we can increase the amount of time that it takes for something to stop itself, that decreases the amount of force on the object. And we see that in real world examples. Cars today are designed so that when they hit something, the front of the car collapses on itself, right? You got this little crinkling sound. I don't know if you guys have ever heard a car crash, but it's like, right? That's because they're not designed to hold together. If a car hits something and crinkles, that is actually extending the amount of time that it takes for something to stop. And again, if the amount of time goes up, the amount of force on the object goes down. We see that in every single type of safety device that we have. If we're talking about cell phones, what the rubbery kind of phone protective case is going to do is it's going to, not a huge amount, but it's going to increase the amount of time and decrease the force on the phone. It happens in cars. Your seatbelt does the same thing. Your airbags do the same thing. When you talk about helmets, football helmets are designed partially with the padding in order to increase the amount of time that it takes to stop and therefore decrease the force. So as we get more into this, we're going to talk about how momentum comes into play. But I'm hoping that you guys can understand what I'm talking about here and kind of summarize why is it that these safety devices work.